In this video, I will show you how to evaluate expressions like sine of a minus b, cosine of a plus b, sine of 2a, cosine of 2a, using our sum and difference formulas and our double angle formulas. And we are given the quadrant of the angles in question. That's what this is. And we're given one trig value for each angle. So let's get started. Let's do the sine of angle A minus B. Well, before we can really do anything, we are going to have to draw a diagram of each angle. So they tell us that angle A is between pi over 2 and pi. That puts it in the second quadrant. So let's draw ourselves a little diagram of the second quadrant like this. Alright, so here comes our angle into the second quadrant. Okay, and for angle A, they gave us the cosine. So we know that cosine is the x value divided by the radius. Now the radius, which must be 17, is always positive. So that means this negative sign really belongs with the 15. So negative 15 is my x value. So I'll put that negative 15 right there. Now you need to do the Pythagorean theorem to find the y value. This is going to turn out to be 8. Now stop and think whether or not this should be negative or positive. This is a y value. Because it is above the x-axis, it should be positive. But don't just automatically put positive. Really think about it. If you accidentally put positive when it should be negative, and imagine this was a test, you would get 6 problems wrong for that one mistake. So it's very simple, but you have to stop and think about it. Now let's so that was angle A. So let's label clearly so we remember that this is angle A. Now let's draw a diagram for angle B, which is between 0 and pi over 2. That puts it in the first quadrant. So we will draw ourselves a little diagram of the first quadrant. Okay, so here's our angle out into the first quadrant. Alright, now for angle B they gave us the sine, which is y over r. So the 5 is the radius and the 4 is this y value. Okay, and this is going to turn out to be 3 when we do the Pythagorean theorem. Again, will it be negative? No, it'll be positive because it's going to the right, but you have to be careful to think about it. So this was angle B. So I'm going to label it really clearly. Okay, so now we're just going to use our formulas. Sine of A minus B. So that's going to be sine cosine minus cosine sine. Okay, so I'm just going to do, so you know what, let me just put this so I can squeeze it in, I do believe. Sine cosine minus cosine sine. So this will be sine A cosine B minus cosine A sine B. Okay, that's what I'm doing. So sine of A, that's going to be 8 over 17. Cosine of B, that's 3 over 5. Okay, now cosine of A, that's negative 15 over 17. Sine of B, That's 4 over 5. So we just have to simplify this expression. So let's see, 8 times 3 is 24. So I've got 24 over 85. Minus a negative is a positive. So I know this is going to be plus. Okay, because this is a negative number, so this will be negative and subtracting. So minus a negative is a plus. 4 times 15 is 60. So I have 60 over 85. So that's going to be 84 over 85. Alright, so that's going to be the answer for A. Okay, now B. So cosine, looking at my cosine formula, so cosine A plus B. So that'll be cosine cosine minus sine sine. So that should be cosine A cosine B minus sine A sine B. So cosine of A is negative 15 over 17. Cosine of B is 3 over 5 minus sine of A is 8 over 17. Sine of B is 4 over 5. Alright, so this is going to be negative 45 over 85 minus 32 over 85. So I have negative 77 over 85. Alright, that's my final answer for part B. Okay, next comes part C, sine of 2a. Well, looking at my double angle formulas, sine of 2a is sine A, well, 2 sine A cosine A. So this will be 2 sine A cosine A. Okay. So sine of A was 8 over 17. And cosine of A was negative 15 over 17. Okay, now to simplify this, please remember that 2 is like 2 over 1. So I'm just going to multiply straight across in numerators and denominators. So this is just going to be, well, negative 240 over 289. Okay, similarly, for cosine 2a, well, I have my choice of 3 formulas. I'm just going to use the first one, cosine squared minus sine squared. So that's going to be cosine squared A minus sine squared A. So I'm just doing cosine squared minus sine squared. Okay, well, cosine A was negative 15 over 17, and sine A was 8 over 17. Both of these are being squared. So when you square something, it becomes positive. So this will be 225 over 289 minus 64 over 289. So this will be 161 over 289 And that's the final answer for part D. Okay, now for part E, tangent. Now there is a double angle tangent formula, but I'm not going to use it because tangent is also sine over cosine. So what I could do is I could just do sine 2a over cosine 2a. And since I just calculated both of those values, it would be silly not to use the facts that I just gathered. So sine of 2a is negative 240 over 289. And the cosine of 2a was 161 over 289. Okay, now I could look at this as multiplying by the reciprocal, but shortcut, I see that the denominators are both 289. So those are going to end up canceling each other out. So the final answer is just going to be negative 240 over 161. Alright, that's the final answer for E. Okay, so the last thing for this video, we will do what is the quadrant of 2a. Now for the quadrant of 2a, we're going to use the values that we found on the previous problems. So what we need to know is what happened with the sine of 2a and the cosine of 2a and the tangent of 2a. We really only need two of these. Sine and cosine, all we really need. So let's look back. The sine of 2a was negative 240 over 289. All that matters, though, is that that is a negative number. Alright, so the sine of 2a was negative. What about the cosine of 2a? Cosine was 161 over 289. Positive. So that's all that really matters as far as determining the quadrant, is that it was positive. Now the tangent is negative. Okay, the tangent was negative. So we just need to think about the quadrant where these things will be true. Alright, so where is the sine function negative? Well, sine is a y value, so it will be negative below the x-axis in the third and the fourth quadrant. Now, where is the cosine function positive? Well, cosine is an x value, so it will be positive to the right of the x-axis. I feel like I should change colors. So cosine will be positive here and here. Okay, so we already know the answer. The only quadrant that satisfies both of these conditions is the fourth quadrant. So the answer is quadrant 4. Alright, but let's follow through and look at the tangent. Where is the tangent negative? Well, the tangent function is going to be negative in quadrant 2 and quadrant 4. So again, we see that quadrant 4 satisfies all three statements. Quadrant 4 is the answer. That's going to do it for this video, guys. I hope it was helpful, and I will see you on the next video.